Hey everybody, I'm Richard Ron with the Leonardo Group and the Lean Design Studio. And I want to spend a little bit of time telling you about lean manufacturing. Now, if you already are familiar with what it is and basically how it works, then you can probably skip this video, but otherwise stay with me and I'll try to make this as concise as I can so you get a better idea of what's involved if you're thinking about learning more about simulation modeling or actually building a model so you know what's happening in the background. And at the end of this short presentation, I'll tell you a little bit about lean simulation modeling and what makes it lean or what makes it different from just standard simulation modeling. So let's start with, at the beginning, to build a model, you really have three stages or three phases. The first is to build the model and gather information, gather data. Second stage is to process that data. And this is where the simulation software is not only useful, but necessary. And then the last stage is reviewing the output, the results. And the idea of reviewing the results is to identify bottlenecks, to look at the performance of your model and look for opportunities to improve that performance. And there are basically two kinds of improvements we're looking for. One is efficiency or productivity. So you want to look at utilization of different resources. Those could be machines or people, or secondary resources like material moving equipment, like AGVs, for example. And the other thing we want to look at improving is throughput. So number of units you would get in a certain period of time by reducing delays and reducing blockages in the flow. So that's basically it. So let's start with the first one, data. And again, I'm going to be going really fast here, but I just want to give you a high-level overview. So the data, for the most part, is similar to the data you would need to have to design a mixed model line in a static format with an Excel spreadsheet, for example. So what kinds of data are we looking to collect? Well, number one, you need to know your products. So we're going to have certain, what they sometimes call entities in simulation modeling. So entities are, in our case, the products and could be the subassemblies that we're going to need to be building in this model. So we need to have a list of those. Second thing is the processes. So by processes, we mean down to the pretty detailed level of individual machines and individual workstations. So you might have a process called assembly, but that's too high level. What we need to know is individual workstations and how they're connected. And so that leads us to the third piece of data, the interconnectivity. So typically we'd be looking for a flow chart or a value stream map where we would understand what is connected to what, which stations are connected to which stations, what is the documentation of the flow. So that's number three. Number four, we would need to have some idea of what we want to build and in what order, the sequence. So this is similar to a production plan, basically. We're going to build this model first and then this model second, and in what quantities. You don't have to build them one at a time. If you don't want to, you could build in batches, but we need to have some description of what that plan is. And then we pull all these things together and the model, and including process times, I forgot about that one. So for every process and every product, we need to know how long does it take to do the work. So that's a critical piece, obviously. So that's the data collection. And if you don't have that data up front when you're building a model, then you're going to need to go collect it. And sometimes that can be the biggest part of the work, is just collecting the data. All right, second step is the processing that takes place. Here's where the black magic happens. So there are relatively few inputs to get the model to run, but the model does need to know how much warm-up time do you want. Warm-up time would be the time allowed to actually run, but not start collecting data. And the reason you want to have warm-up time is so you can fill the line. If you just started collecting data at time zero, nothing's going to come out for a while, right? Because the first unit is going to have to make its way all the way through the value stream or the processes. So we fill up the line first, or we wet the line with some warm-up time. And then we have the actual data collection time. That's the second piece of information that the model is going to need to know. So how long do you want to run it for in simulation minutes or simulation hours? Is it a shift's worth? Is it a day's worth? Do you want to run it for a week's worth? The software doesn't care. It'll just run for as long as you want to. But typically we would run it for a day's worth or a week's worth, something on that level to assess the output. Now, of course, the longer your takt time, the longer you're going to want to run that model, because otherwise you won't have enough instances to really get a good measurement of the performance if your work content time is longer. So keep that in mind. So what happens during this black box period is that the model is going to run and keep track of the time. So it's going to be moving these entities through the model. And when it gets to a station, it's going to look at how long that entity should be at that station, and it's going to stay there for that amount of time. And then it's going to move it to the next step based on your description of the flow. And so it's going to proceed like that, but at computer speed. So it can go through a week's worth of work in, relatively short time. I'm talking seconds or a minute or so to complete that kind of processing. So much faster than real time, clearly. And as it goes through and moves these entities through this flow, it's going to keep track of how much time these entities are being worked on, or they're waiting, or they're finished at a station, but they can't move on because the next station downstream is busy. So that would be a condition of being blocked. Or you could have a case where you have a resource like a workstation and the resource has nothing to work on. So they're not blocked, but they're just have no demand, basically. So there are various scenarios that can happen, and the software, this black box simulation software, will keep track of all of those things. And then, of course, we come to the third step where it reports back to you the results at the workstation level and at the individual operator level. So if you have 10 operators, it's going to show you 1 through 10 how much time was spent working versus waiting versus being blocked, etc. And so that's very useful. For example, if you found a resource that was utilized 100% of the time, that's a pretty good indication that that resource could be a bottleneck. You don't have enough of that resource, and therefore that one resource needs to be totally busy all the time, 100%. So that'll be a red flag that maybe we need to add more resource there or take away some time by improving the process. So that's the beauty of this simulation modeling methodology, that you can actually see this data. And if you describe the actual flow with reasonable accuracy, you can get a pretty good idea of where the bottlenecks are going to be and where you need to focus your attention on improving the process. And I'll have to warn you that in a mixed model environment, if you design it in a static environment, design your flow for, say, 100 units a day, that's your capacity goal. If you have significant enough variability in those processes, you're not going to be able to get to 100. And the static calculations won't show you that. They won't show you that because the static calculation is not testing for the interrelationships. It's not trying to anticipate, per se, the block time and the waiting time. So that's where simulation modeling can be very useful to give you a more realistic view of what you can expect to get from this design. And of course, the higher the variability, the more impact that's going to have on your throughput, because more time is going to be spent waiting and being blocked. That's the essence of it. Okay, final point. So I understand this is very high level, but we've got to start somewhere. And what is different about lean simulation modeling? Well, in a sense, nothing. We're modeling a process, but there are a couple of characteristics of lean types of projects that are maybe different. When I did my first simulation modeling project, it was in business school, my MBA program. And the case we were supposed to work on was a ski area. Of course, I'm here in Colorado, so that would be a good example that we're familiar with. But in a ski area, you have a couple things that are different from a factory. Number one, you have a random arrivals, like people are showing up in the parking lot at random times, right? Depends how early they got up in the morning and fought the traffic to make it to the ski area. So that's something that you want to test for. If you're a ski area, you want to have some sense of what to expect. But in a factory, you don't have random arrivals. You have a production schedule that's fixed ahead of time. You know which one you're going to start first and which one second. And they're all, in a sense, they're all waiting there, waiting to be pulled into the flow. So that's one difference. The other big difference is that typically in a lean environment, this doesn't have to be true, but typically we're modeling value streams that are linear, that flow in one direction from the launch of the product to completing the product. Whereas in an environment like a ski area, it's more circular, right? People are going up the ski lifts and they're coming down the slopes and then up the ski lifts and then arriving in the parking lot and then leaving in their cars. So it's less of a linear flow. But again, we could be modeling a lot of things in a lean environment. But for the most part, I would say in most cases, we're trying to model a value stream which starts on the left side of the page and it finishes on the right side of the page. Okay, so I think that's good for starters. There's a lot of interesting material out there in the world if you want to dig deeper. But I thought I'd just share this with you as a way, if you're new to the subject, of starting to get familiar with what simulation modeling is all about. So we'll see you next time. Bye-bye.